Hey guys, welcome to day 5 notes. This is basically the continuation of yesterday's modules. Okay, so on day 4 you looked at what slope represented, how scatter plots can be, worked with slope and how to create a line of best fit. But for today's video, today's a little tougher day in terms of the material that's out. So I'm going to keep it real straightforward. We're going to just focus on these lesson sheets. You have some homework to do in here and then an assignment. Okay? So we'll keep it nice and straightforward. This video is going to be very specific to the document that you'll be looking over. Like always, I've highlighted all the main topics in green, and then at the very end of this booklet you have a couple of questions that you need to work on, which goes through linear relations. Okay, all right, so we'll take a look at day 5 and we'll see what we have in store here. Okay, so linear relations and analytic geometry. So there are 3 ways to determine a linear relation. Okay, so these are the 3 ways that I'm going to go over. The first way is if the equation has a degree of 1. So if an equation has a degree of 1, that means that the highest exponent of x is 1. Okay, so some examples of that could be y equals 2x, y equals 3x minus 1. But anytime you see the highest exponent of x, if that is indeed 1, so you might not see the 1 there, but it is indeed implied that it is present. Okay, anytime you see anything like y equals x squared, that tells you that that is not linear. Okay, so the main look has to be one of these ways. It could be y equals mx. In the textbook that you might have used at your home school, they might use y equals kx. That represents direct variation, or it could be y equals mx plus b, which is partial variation. Direct variation graphs have a y-intercept at 0, 0, and partial variation have a y-intercept anywhere except 0, 0. So even looking at this diagram here, you can see the y-intercept is at 0, 3. So this has to be partial variation. Okay, whereas if I drew a line that went through the origin, this would be direct variation because it goes through the origin, which is 0, 0. Okay, but needless to say, we know it is linear if the equation in its equation form has the highest exponent of x is 1, or the degree is 1. Okay? All right, the second thing that we're going to focus on, and this is very straightforward, if it looks like a line. Okay, so some graphs may look linear or nonlinear. Nonlinear can be a curved graph, a parabola, or anything that does not look like a line. So very simply, if it looks like a line, then it's probably a line. Okay, so lines can look like this, and there's a couple of other variations that we'll go over in this lesson sheet. Okay, the third way to determine if it is linear is if the first differences are the same, so if they are constant. So we took a look at this in the day 4 notes. Okay, so you can see here, if we were to find our first differences, so I know this is already done for us, but remember, we would do 5 take away 4, which would be 1, 4 take away 3, which would be 1, 3 take away 2, which would be 1, 2 take away 1, which would be 1. Also observe your x values, so you'll notice that they also increase by 1. And if they are constant, meaning if they are the same value, then that means that this is a linear relationship because the first differences are constant. Okay? Here are some notes that you guys can read up over the difference between direct variation and also the difference between partial variation. Alrighty. There are 2 ways to express a linear equation. So slope form might be more familiar to you, y equals mx plus b, but there is also something called standard form where we have ax plus by plus c is equal to 0. You spent some time yesterday working on how to determine slope, so looking at rise over run, so you probably have gone through the quizzes and the modules that help show you that. Okay, so remember m is just another way to say rate of change. And rate of change exists in so many ways. Okay, so for instance, if you have, I've used this example before, if you have a part-time job and you earn $14 per hour, every hour that is worked, you earn $14, right? So 1 hour would be 14, 2 hours would be 28, and so forth. That is your rate. Okay. Similarly, if any of you guys babysit part-time, you might be charging $10 per hour that you spend with the little one that you're babysitting. So for every hour of work, you earn a certain amount of money. This exists in so many ways, right? That might exist in purchasing semi-tickets. It might exist in purchasing apples, oranges, or if you're buying tickets, if you're trying to rent a hall. Lots of different examples I'm sure you've seen over your time. Okay, so slope or gradient measures the steepness of a line. Okay, so for instance, steepness refers to if you were a person walking on that line, we can consider a line that is more steep and a line that is less steep. Okay, a line that is more steep has a higher m value. So for instance, if m is equal to 5, that would be more steep than a slope of a line that might be equal to 2. Okay, a value that is less steep would be close to 0. So let's say if I do m is equal to 1 over 2. So the higher the value, the more steep it is. So again, think of a treadmill, think of you walking up a hill. The higher or harder it is to walk up that hill, that means it has a great steepness, or in other words, a great rise over run. Okay, there are two ways to express slope. There's delta y over delta x, which stands for change in y over change in x, which pretty much is our slope formula, y2 minus y1 over x2 minus x1. So observing what happens between 2 points, and of course looking at rise over run. There are, though, 3 ways that we can graph. Okay, so this goes over the 3 ways in this little document here. Okay, so start at your y-intercept and apply rise over run method, so I can show you what that looks like. Using a table of values, it is straightforward, right? We know that we just have to sub in different values of x and find our output for y. However, it's a lot of work. You might realize that, using rise over run method actually is a little more quicker, because once you get the pattern down pat, you're good to go. And the third way is find your x and y intercepts. Okay, so an x-intercept always has a value of a number, comma 0. And all y-intercepts always have 0 and then whatever numerical value. So find your x and y-intercept. So if this was our Cartesian plane, let's say my x-intercept is there, that's where my y-intercept is. You would take those 2 points, draw a line, and that would be another way to graph your linear equation. Okay, I'm going to go over those types of graphing, and I'm also going to go over different types of slopes. So in total, there are 4 types of slopes depending on the line you're considering. Okay, so for one, there is something called a positive slope. A positive slope increases to the right, and it's ascending. Okay, so you can even see here in this example of slope, I would say the slope is at rise 3, run 5. Okay, and you can see it's gradually increasing. Negative slopes look like downhill graphs. Okay, so in this case, the rise is moving up or to the left, or we can actually consider moving down, so going from one point to the other. Okay, so again, this looks like it's descending, so it's a higher left, lower right. Okay, in this case, you notice all negative slopes, I gave that away. All slopes are negative. So you know to slap a negative sign in front of that slope if it looks like this, if it looks like it's decreasing. The third type of slope is a zero slope. So this is your horizontal slope, and this is when you have your flat line. Okay, so you'll notice there's actually no rise between the 2 points, but there is a run. So m in this case would be 0 over 5, which would just be 0. Okay, and last but not least, we have our undefined slope, which is a vertical line. And it's undefined because if you take any value and put it over the number 0, you actually can't calculate that. So even if you stop and grab your calculator, it is not a number that exists in our number system. So it is an undefined slope. So if it's undefined, you literally just have to write undefined slope. You don't need to leave it in numerical value. You can just say undefined if it asks what type of slope it is, and that's more than okay. All undefined slopes are vertical, so they look like this type of line. Okay? All right. So we're going to take a look at some questions here. Okay, something that I wanted to highlight is when you're trying to find slope, you always need two good points. Okay, so a good point, as you can see here, is one that you can clearly identify. I know that that is clearly 5, negative 4. Oops, I just got to write it clearly. 5, negative 4. And we'll pick another good point. So let's say, you know what? This is a clear point. 6, negative 1. Okay? So a trick that your grade school teacher might have taught you is you can make a right angle triangle. You would count how much rise. So that would be 1, 2, 3 is your rise. And then 1 is your run. So the slope would be 3 over 1 or just 3. And remember, m is equal to rise over run. Okay. For our second example, so again, choose two good points. So I'm going to choose this one, and I'm going to move up to that point right there. Okay, so again, you can draw your right angle triangle. Oh. There we go, it's a little better. You're going to count how much rise you have. So that's 1, 2, 3, 4, 5. Oops. So we want a 5. And then we ran 1, 2, 3 to the left. Okay, so your slope is going to be 5 over negative 3, or negative 5 over 3. Okay, now remember, you always want to find good points. So even like these points here, those are a little hard to determine, right? They look like decimal values because they're in between. So make sure you pick a good point that you can clearly identify. Okay, your slope here for your third example, you'll notice this is a horizontal slope. All horizontal slopes have a slope of 0. Okay. And this is a, so for rise, you could say 0 over, and then I'll pick two good points. So let's say I pick those points. So 0 over 3, which is just 0. Okay, for our vertical line, again, all vertical lines have a undefined slope. Okay, so we definitely have rise. So if I chose those 2 points, so it has a rise of 2, but no run. And remember, any value that has a 0 in the denominator is an undefined slope. Okay? Okay. Let's consider how to use the slope formula, okay, to calculate the slope, okay? So really straightforward. One thing that I always tell my students when I teach this in class is first always write out your formula, okay? The next thing you should always do as well is always identify which one is x1, y1, x2, y2. So the reason why point A, I've just dictated that as point 1. So it's going to have an x1, subscript 1, y subscript 1. B, I'm going to call my point 2. Okay. Now I'm just going to write out my values. So I wrote out my formula first. I'm just going to go horizontally because I don't have much room below. So I'm going to do y2 minus y1. So that'd be 1 take away negative 2 divided by 6 take away negative 3. Okay, you have to remember your integer law. So 1 minus negative 2 turns into 1 plus 2, which is positive 3. And then 6 minus negative 3 turns into positive 9. Always reduce when you can. So 3/9 is the same as 1/3. So therefore m is equal to 1 over 3. Okay? Alrighty. Let's take a look at how to graph lines, okay? And there's the 3 ways that I was talking about. And we're actually just going to graph all these lines on the same grid. Okay, I'll do some color coding. So I'll do blue, sure, for the first one, or purple, whatever color that is. I'll then do like a pink for a table of values, and I'll do an orange for an x and y intercept. Okay, just to keep everything clear. So let's find that color, or one close to it. Okay. So slope and y-intercept equation. So draw y equals negative 2 over 3x. So already I want you to recognize that that's a negative slope. So remember, all negative slopes look like this, where they are decreasing to the right. Okay? So what you should always do is always start at your y-intercept. So I'm going to start at 0, 7. And then I'm going to apply my rides over run. Okay, so from 0, 7, I'm going to go down 2 and then right 3. 1, 2, 3. And then place that dot. Okay, I'm going to repeat this motion, down 2, right 3. And then once I have those points, oops, I'm going to, ooh, that's not a good line, connect those dots, and there we have it. That is point, or line I. Okay. Now, like I said, for the table of values, it's possible. I'm going to show you anyways because it is a method that we can do. So I'm just going to take my pink. Okay, so I'm going to find different values of x. So I'm just going to do negative 1, 0, and 1. Again, you could choose any ones you want. And what I'm going to do is sub in all of these values of x into my variable. Okay, so I have 3 over 4 times negative 1 minus 6. Okay, so that's negative 3 over 4 minus 6. Okay, so again, I have to make this a common denominator. So I'm going to times this by 4 times that by 4. So 6 times 4 is 24. I'm just going to rewrite this because I'm running out of room. 24, so times 4 times 4. Okay, so then if that simplifies, that should be negative 27 over 4. Okay, sometimes they're not pretty, sometimes they are. Okay, this one will work out nicer. 1 minus 6, well, at least I hope so. Okay, 3 times 1 is 3 over 4 minus 6, so 3 over 4 minus 24 over 4, negative 21 over 4. Okay, and if you want, you can always turn that into a decimal just to see where you would plot that. Okay, all right. And then last but not least, 3 over 4 times 1 minus 6, so that's 3 over 4. Oh, wait. I did the wrong one. Sorry, guys. Okay, I'm going to copy the answer down here. So that's negative 21 over 4. I already showed you the work. I just subbed in the wrong number up top. Okay, so this is supposed to be a 0. Okay, there we go. So we got our 3 coordinates. Okay, so I have negative 1 and negative 27 over 4. I have 0 and negative 6, and then I have 1 and negative 21 over 4. Alrighty, so let's figure out where 27 over 4 is. So I just typed that into my calculator. It's about 6.75. So negative 1 and then negative 6.75. So that's somewhere down there. Okay, 0 and negative 6, that's somewhere there. And then 1 and negative 21 over 4, so 21 divided by 4 is approximately 5.25. So somewhere there. Okay, so as you can see, it's not the most accurate way. However, it's a good default way. Like if you don't know what to do, table of values. However, I do recommend this first way, even going into grade 10. It's the fastest way. You plot your y-intercept, you go rise over run, and you're good to go. Okay? I always recommend that way. Always, always. Sometimes, though, there's an x and y intercept method that you can apply. So to find your x-intercept, you have to sub y in for 0 and solve for x. So let's do that here. So I'll say x-intercept. So that's what we're trying to find. So 4x plus y equals 5. Okay, so I'm going to sub in y in for 0 and solve for x. X equals 5 over 4. Okay, 5 over 4 is approximately 1.25. Okay, but leave it in that fraction. It's better off this way. Okay, then for your y-intercept, you're going to now sub in x in for 0. Okay, 4 times 0 cancels out, so I have y is equal to 5. Okay, so basically, let's go to our Cartesian plane. I have an x-intercept at 1.25 and 0, and I have a y-intercept at 0, 5. Okay, so what I would do there, I would draw in my x-intercept, so 1.25 and 0, and then 0 and 5. And then, that's a terrible line, let's do that again. That's good enough. You would use a ruler at home, of course. Okay, and then that would be your third line. Okay, so you have these three methods that you can use to graph. Again, I do recommend slope and y-intercept form. It's just so much more straightforward and it's easy to identify. Okay, all right, let's move on. We're going to go through this little investigation on perpendicular and parallel lines. Okay, so something that you'll notice is lines that are parallel run in the same direction, but they actually don't intersect. Okay, and if you ask, or if I ask you what kind of slope is this, we can say, well, that's a zero slope because it's a horizontal line, if you recall. All right. If we look at these two lines, line 3 and line 4, remember we call those vertical lines. And the slope of a vertical line, remember, are undefined. Okay, so what this means is lines that are parallel have the same slope. So m of one line equals m of the other line. Okay, so even if I were to calculate the slopes here, that would be rise 1, 1, 2, 3. So 1 over 3. And again, same here, rise 1 over 1, 2, 3. So you can see your slope is the same value. Okay, so if they are parallel, they have the same m. Now, we're going to just recall what happens when they're perpendicular. Okay, so perpendicular slopes look like what we have here. So they intersect each other and they actually form a 90-degree angle. Okay, and why that's important for both examples is we're going to find the slope of, let's do 8 and 9. Okay, so we'll take a look at the slope of 8. Okay, so that slope for this one would be 2 over 1. So again, rise, oh, sorry, that was the wrong line. Rise 2, run 1, okay? The slope of number 9 is actually negative 1 over 2, okay? And then we'll do it for slope line 10 and 11. So you should get a slope of negative 4 over 3 for number 10, and then a slope of 3 over 4 for line 11. So what you'll notice is these slopes will always be negative reciprocal slopes. So lines that are perpendicular always will have perpendicular relation, so negative reciprocal slopes, and when you multiply them, they always equal -1. So let's take a look at lines 8 and 9. If I multiply 2 over 1 multiplied by -1 over 2, I get -1. You can see that your result will always be that. Okay, so as a way to check, that's something you can do. How to find a negative reciprocal slope? You'll notice, so for instance, if I start with the whole number 2, that's 2 over 1. What I'm going to do is I'm going to flip the fraction. So instead of 2 over 1, it becomes 1 over 2. And we're going to change the sign. So you'll notice the first value is +2. So that means our negative reciprocal has to be -1 over 2. Okay, similarly, if we look at these lines, -4 over 3, we would flip those values. You would get 3 over 4. Since that one's negative, then this one has to be positive. Okay, those are really, really key important information points that you should keep in mind. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Hopefully that makes sense. Okay, we're going to move on to topic D. Okay, so we're going to determine the equation algebraically. So as you saw above, to write an equation in y equals mx plus b, so in our slope formula, we need two parts. Okay, so one, you need to know the slope, and two, you need to know the y-intercept. Okay, so where the graph crosses that y-axis. Okay, so I'll let you read over this on your own, but basically I'll summarize it. There are going to be three types of ways that, situations that you might be given to help figure out what that line is in y equals mx plus b. So sometimes you're given a slope and a point, and that point that it passes through, of course, a coordinate is xy, right? All coordinates have that xy representation, okay? Sometimes you might recall from earlier in the school year, you are given 2 points. So from there, you would have to calculate the slope first, and then you would have to use one of those points to help figure out what b is. Okay, but in all equations, you're always looking for m and b. And then we're going to sub them into the skeleton, which is y equals mx plus b equation. The third part is we might be given something trickier, so an equation of a line. So remember, we just talked about conditions for parallel lines. Okay, so a line parallel to y equals 2x plus 3. Well, I know all parallel lines have the same slope. So a line that would be parallel would be 2x minus 1. So same slope, different y-intercept. For lines that are perpendicular, okay, so again, look at your slope. That's 2. We actually just talked about what happens when we have a slope of 2. Okay, so we got to find the negative reciprocal. Negative reciprocal of +2 is -1 over 2. So that would be my new slope. And then we would just need any y-intercept, so it could be -2. Okay, so sometimes you might have to find equations with these conditions. Okay, so first I'm going to walk you through how to do it. So you have your steps, so step 2, step 3, and then I'm actually going to show you what I do with my classes when I'm in school, but it's something called a what I know chart. Okay, so it's always good to identify what you do know and how to apply it. So in this question, it says, determine the equation of a line in y equals mx plus b. It has to have a slope of 2, so again, that's m, and passes through the point 2, 5. So remember, any coordinate is just xy. Okay, so what I'm going to do first is I'm going to write y equals mx plus b. And then in my organizer, I'm going to write out y equals mx plus b, but just the variables. So not the equal sign, not the plus sign, just y, mx, b. Okay, I'm now going to write everything that I know. So remember, I know my slope. My slope is 2. If it goes through that point, they give me an x and they give me a y. So again, x is 2, y is 5. The only thing we don't know is our y-intercept. So what I'm going to do, I'm going to take all of these things that I do know, and I'm going to sub it into y equals mx plus b, and I'm actually going to isolate for b and find it. Okay, so instead of y, I'm going to have 5. Instead of m, please replace it with brackets because you're multiplying mx. Instead of x, I'm going to replace it with 2, and I'm going to isolate, like I said, for b. Okay, so that algebra stuff that we did a couple days ago, we need to recall what our algebraic steps are. So if we're trying to isolate for b, remember we talked about SAMDEB. Okay. And we got to see if there's anything I can do. So right now, I should actually be dealing with multiplication because that's what I see first. Okay, so 2 times 2 is 4 plus 5. Actually, you know what? Even before SAMDEB, we would simplify that. Okay, so I apologize. You would simplify first and then apply SAMDEB. So in this case, if we want to isolate for b, again, we would have to bring over that 4 to the left side. So I would have 5 minus 4 is equal to b. 1 is equal to b. There we go. Okay, so remember, our skeleton is therefore y equals mx plus b. So for m, we got 2. That was given in the equation. So I'm going to do 2x, and then I'm going to replace it with my b value plus 1. Please leave x and y in there. They are part of your skeleton. They need to be there. They're your backbones. But you always only replace, like I showed you up here, m and b to write an equation, right? So example, y equals 1 over 2x plus 5. Y equals negative 2x minus 1. We keep m and b, or we write m and b, but we keep x and y, okay? All right, hopefully that's clear. I could do one more, just so we can see how I set it up. So I'll do A. Okay, so what I know, so remember I write out y equals mx plus b, and I'm just going to go into writing out y equals m equals x equals b equals. Okay, so I know my slope is 5, so for m I'm going to write 5, and I pass through the point x, y. So 1, 6, so x is 1, y is 6, and I don't know b. Okay, so once again I'm going to isolate for b. 6 equals 5m times 1 plus b. 6 equals 5 times 1, which is 5 plus b, so multiply first. Then we'll bring over 5 to the left side, so it would be 6 minus 5 is equal to b, so 1 is equal to b. Okay, so therefore your equation, we're going to do y equals mx plus b, where m is 5 and b is 1. I obviously went really quickly. Feel free to slow me down, stop the video, and try to review. Sometimes you might have to watch videos twice. First time for just listening, and the second time for actually processing. Okay? All right. And 2 more things, okay? So for E, if we want to determine the equation algebraically with 2 points, so meaning we're actually given 2 values, and we got to do that same thing where we have x1, y1, x2, y2. Okay, so the first thing that we have to do in the instructions is calculate m. Okay, so first figure out what m is, and then we're going to use one of those 2 points for x, y, and we're going to solve for b. Okay, so same thing, what I know chart. So y equals, m equals, x equals, b equals. Okay, I'm going to write out y equals mx plus b, just so I have it ready. But first, I need to calculate slope. Okay, so m equals y2 minus y1. So it's going to be negative 1 minus 6 divided by x2, so negative 4 minus x1. Okay, in this case, I get my slope as 1. So I'm going to take that 1 that I just figured out, and I'm going to write it in for m. Okay, now I'm going to choose one of these 2 points. Doesn't matter which one I choose. I'm going to pick the first one just because I see it there. So x is 3, y is 6. Remember, you could have used -4 and -1 for your x and y. It's up to you, okay? Then I'm going to sub in what I know. So 6 is equal to m, which is 1, times x, which is 3, plus b. Please multiply m times x, so I should get 6 equals 3 plus b. Okay, and I get b is equal to 3. So in my equation, I should get, therefore, y equals 1x plus 3. I don't even need to include that 1. It's understood that there's a coefficient of 1 if you just write x. Okay. I also note here there will be certain scenarios where you will have to consider perpendicular and parallel lines. So again, like we talked about in these examples. Okay. Okay. The last thing I just want to discuss is topic F. So this is converting from standard form to slope y-intercept form. Okay. So I want you to consider here, standard form is ax plus by equals c. Sorry, ax plus by plus c is equal to 0, where a, b, and c are numerical values. We can say numbers. And a and b are both not the same. Sometimes they are, sometimes they're not. But I'm just saying for this case, they're not going to be the same. Okay? All right. So in this, we need to basically transform ax plus by plus c equals 0, and we're going to change it into y equals mx plus b. Okay? So that means we need to isolate for y, because you'll notice y is by itself. So this is where your algebraic steps actually become really helpful. Okay, so remember what we were doing in the algebra stuff from, I guess that was day 2 stuff. Okay, so when you're doing that, we need to figure out how can we isolate y. Okay, so what we're actually going to do is we're going to make our lives a lot easier, and we're just going to bring over that y term, and we're going to bring it to the right side. Okay, so if we bring it to the right side, you know what? Sorry, this blank should be are both not 0. That makes more sense. There we go. Okay, let's go back to this. So I'm going to take -3 and we're going to bring it over to the right side. So I should have 2x minus 6 is equal to positive 3y, because once I bring it over, it changes its sign. 2x minus 6 equals 3y. To isolate for y, remember, we just divide by the coefficient. Divide by 3, divide by 3, divide by 3. Those cancel. So I have y equals 2 over 3x. Do not divide that out, because remember, that tells you your rise over run if you have to graph it. Okay, so therefore, isolating y, the equation is 2 over 3x minus 2. It's now in slope y-intercept form. Okay? Okay, so I just went over all that stuff. Hopefully it makes sense. We're just going to focus again on this note and the assignment. What I'd like you to spend some time on today is actually looking at this beautiful homework package I made you. Okay? I know doing these questions will definitely lead you towards success. Okay, so making sure you know how to do all these types of questions first and then doing the assignment. Okay, so you can see that some of the answers are at the very bottom. And again, you just pick and choose what you think you need to do to understand this whole entire unit successfully, including the stuff that we did yesterday. Okay, all right. So yes, this is a 21-page document. That's all for me. I just went over all of your notes. Please do your homework and also the assignment that will be assigned after you do this selection and homework. You don't need to hand this particular PDF in, but you will need to hand in